Alrighty guys, I figured I'd kind of jump right on in here and take you through exactly how to design that nose cone I did the other day. So to kind of get started, just open up a new part and open up any plane, it doesn't really matter. And then just go on up in here into the spline feature and go to the equation driven spline on the drop down menu. Now for this type of equation, for this kind of nose cone that we've kind of chosen, we're going to have to use a parametric equation, so just make sure to check that off. And check the comments for the equation. I have mine right here, but just check in the comment section and there will be this that you can just copy and paste right into your equation. Drop boxes, just follow where I put them. But essentially you're going to put one part of the equation in your xt, and you're going to put your yt in your yt. And I pretty much already did all the converting, but essentially I got this equation from here because we're designing an LD von Karman series or Haack series nose cone. We're doing this 0 C value one. And so if you want to learn more about the nose cone or just about the other ones in general, you can go to the nose cone design wiki. There's a lot of decent information, and there's actually more references in the bottom that you can use to look at some more information. But essentially this is kind of where I got the equation from, and I adapted it as best I could to SolidWorks. I still need to double check to make sure it's right, but essentially we're integrating from 0 to 14 because the normal height of the nose cone is 0 to 14 inches, but since we're giving it a fineness ratio of 3 and extending the height 3 times, we're actually going to have to keep it at 14 and then scale the entire thing together so it keeps the same ratio, because then that should give us the same the radius that we need. So yeah, just make sure you plug those into the right fields, and your T1 should be 0, T2 should be 14, and just go ahead and hit check. And now this is where I'm actually going to go ahead and draw a center line for myself that I can revolve around and check the diameter essentially. So essentially from here I'm going to scale this entire nose cone to the 42 that I want. And as you can see here, the profile didn't really change at all, and we got our 42 for the height. So now if we check the radius, okay, so it's actually a little bit shorter than what we want it to, so we might actually be able to scale the radius to what we want, and the height will follow. Now this should be a little, yeah, 43. That's fine. We can always do some modifications later on, but essentially this gives you your nose cone with the base radius of 7 and a little bit higher than a fineness ratio of 3. I don't really think it's that necessarily important that we get a fineness ratio of exactly 3, but that's something we can always check later on. But from here, essentially you pretty much have your nose cone outline. And from here, this is where you can do an offset entity to have the thickness of your nose cone. So say if we're going to make this out of like a Kevlar skin, this could be your, or epoxy skin or something like that, or a carbon fiber matrix composite thing, nose cone, we can have the thickness right here. But for now, I'm just going to go ahead and extrude this as a solid block, because I'm actually going to be running some really simple CFD analysis on this to show you kind of how to do it, and having a solid shape is the same as having an outline essentially, but this is essentially the outline that you want, and I'm actually going to go ahead and close the shape, and then I'm going to go ahead and revolve it 360, yep. And boom, there we go. That's pretty much our shape of our nose cone. And this is at least one of the ones that I want to explore. If you notice in the comments, I'm actually going to have 2 nose cone designs, or actually 2 nose cone equations. And if you go to the wiki, there's actually a bunch more. And one of the ones that I'd really like to look into again is this power series, and look at the 1/3 series, or the 0.5 series, sorry, the 1/2, which I believe is this curve right here. In our initial research, that one performed pretty well too, so might as well model it for some practice and to compare. So just follow essentially those steps with that equation, and you should get the general shape. Now this is kind of where you can continue to model. So this is where essentially I would go into configurations and cut away sections so I can have the nose cone tip and then the skin, and then have the central load bearing rod and things like that. You don't have to model it that way, you can do it in parts, but I would just do it configuration wise, and I kind of explained how I did that in the other video, so I don't feel the need to really go through that. And I'm going to go ahead and get started on the CFD video to kind of show you how that's done. Alright, see you guys.